Bueno, vaya presentación, ¿eh? Madre mía. So, hello everybody. I will do the presentation in English. I think that it will be fine for all of you. If you want to make questions afterwards in Spanish, it's Spanish, Valencià, Català, whatever you want. Okay? Okay. So I'm Jordina Torrents. I'm leading the efforts on artificial intelligence in HP, specifically on large format printing. Right. First of all, I think that my presentation was swapped, right? Because I just wanted to do it in the morning, but it was more difficult to arrive from Barcelona to Valencia than training a large language model. That is what we will talk about today, okay? But I'm here, so let's start with the speech. My speech is entitled Artificial Intelligence in the Long Term, and we still don't know how far we are from artificial general intelligence, okay? So we will try to link this presentation, which is next, right? Which is artificial general intelligence and how HP is making efforts on applying this kind of intelligence in the software stuff, right? Because when you are thinking about HP, you think about the printers, you think about the hardware, and that's not all what we have, right? We have other things that you will see here today, okay? All these kind of efforts that we are making for jumping to this kind of hardware company to a more software-based company is from the construction services area. So I will talk a little bit about this. Okay, let's recap what we have here to put you in context, right? So I'm not sure if you know, but more or less 30% of the construction projects that we have in United States are based on restoration, rehabilitation projects that we need to, that architects need to rebuild again all the building or do some modifications or some stuff there. That does not mean that we also have, these kind of big buildings like skyscrapers where you just see, oof, what's that like in Houston, okay? So the point is that the complexity of this kind of architectural designs is quite hard to understand. So when you have like a drawing plan, you need to know exactly what is there, right? The architect just put a lot of information there in another language that maybe we don't know or other kind of people don't know. And we need some deeper knowledge to understand that, okay? And this is even more difficult, even for human experts, when there is some modifications on the drawings, when there is some sketches there, when there is some things made by handwritten annotations that you need to interpret as well, okay? Because the difficulty, the complexity for making this kind of interpretation of what we have in the drawing plan is a little bit more difficult, right? And this is not the only point. The other point is that there are different key players here that are trying to understand the drawing plan, not only the architects, who is the person who is building that, but also the contractors, right, that are reviewing these kind of drawing plans, what the architect wants to do. They need to understand it very well, they need to interpret it very well, and then they need to build, right? If the results are not what the architect expects, there is a lot of problems there, legal issues, So let's put an example. What about a rehabilitation project, right? A rehabilitation project stands for, okay, let's find the original drawing plan that maybe it will be very, very old. There will be a lot of things here that we need to interpret, but the drawing plan, the original one, will be used as a reference of the new project, right? What we need to do, right? In many cases, all these drawings are, as I mentioned, old. There is a lot of handwritten annotations. There is a lot of sketches that we need to interpret, right? So that it's even more hard to make this kind of interpretation and understanding. So these kind of drawings, the process to do that is like some time ago, the drawing was printed, right? And then when the architect were to make this kind of rebuilding or this kind of restoration, they will scan the drawing again. They will try to digitize the drawing. That means that they want to convert it to, digital. They want to edit some things there. And afterwards, there will be like an open path to make a lot of modifications and to propose different ways of making this kind of architectural building, right? Like making it more sustainable, like making it more optimal, all these kind of things that you already know. So what we need to point out here in this presentation is that there is 4 key processes here. So we have the printing, which is creating something physical. We have the scanning, which is trying to record something in a digital format. Then we have the process of digitization, which is a key point here, is generating something editable, because you're making this kind of transformation between the physical wall, Excel like that, and the digital wall, because you can modify the drawing plan. And afterwards, there is a key point here, which is understanding, right? That is fostering some kind of intelligence behavior so that we can understand properly what is there in the drawing plan. So our proposal here is that we cannot say that architectural drawings can be understood only as a geometrical recognition problem, but we need to say, okay, what happens if we try to apply here language, different algorithms to understand it as a language understanding problem, right? And here we are bridging the gap. We are making the transformation between what is digital, what is physical, sorry, and what is digital. And we are moving from one to the other one. Okay, so as you realize, these kind of architectural, engineering, construction workflows are moving constantly from digital to physical. Architect made some annotations, then print the drawing plan, then they need to scan it again, they need to digitize it, then contractors need to understand it. So there is a lot of things here, and HP was working on that quite a bit, right? So which is our objective? This is quite important to understand before moving forward, right? What we want to do, or which is our intent, is try to collect all these files and use artificial general intelligence so that we can put a layer of semantic interpretability on all those drawings, and then we can provide the user from more information and for new functionality. So we can open here a lot of use cases that are new for HP and can be, let's say, monetize from different solutions, right? One of them, it's, okay, we will provide, like, imagine that we have like a huge agent, a huge artificial intelligence that will have the ability to recognize building elements, views, spatial relationships, that is very important in a drawing plan. It will have the ability also to help understand people how the building will look like in the future, and also how it will function, okay? Which kind of things we will do here. Then we can also propose another thing, because it will be an intelligent agent, and we can make this just design versus reality, what's happening here, right? Imagine that we have a 2D drawing, which is what the architect was designing, and then we have the reality. We can capture the reality using, for instance, 3D point clouds, and then we can make like a registration between the 2D and the 3D wall and see what happens, right? To enhance the quality and progress check during the construction. And this kind of registration, if we have an artificial general intelligence agent that is able to understand the 2D drawing plan, it will be able to move also from 2D interpretation to 3D modeling. That is what we call in construction services BIM, right? Using different through multimodal language capabilities, okay? Another business case that we'll have will be, okay, let's uncover different legal aspects. Because, and when the architect is designing the drawing plan, is like, okay, in which country you want to build that, right? So you need to take into account the legal aspects for that particular country. Otherwise, you will not be able to do it, right? And we can also help the architect with these kind of agents to see, okay, which are these kind of legal issues that we need to fulfill, and how we can just generalize it to worldwide, okay? And other kind of use cases that you have here, how to generate vectorized drawing plans with different language models, and how to optimize and boost what we talk about building performance simulations, right? Once you have the drawing and you understand what is there, you can just simulate, for instance, the people flow, acoustical things, thermal things, and all this stuff. So we can optimize a lot if we understand the drawing plan. Okay, let's go a little bit more deeper, right? Which is the difference, very, very briefly, between what we call narrow AI and what is called artificial general intelligence, right? I think that most of you will know, but narrow AI, it's very focused. It's when we have a system that is specifically designed for solving a single task. Okay, you just train the model, you want to solve that particular single task, and maybe the model will perform even better than humans, right? Because it's specifically designed for that. But what happens here? It's like, it's not programmatically, but you just implemented to do that. So you didn't have this kind of, let's say, consensus cognitive capabilities that human has, and you are not able to generalize all this knowledge that you have for this specific task to another narrow task, right? You can generalize it even if you are making a classification model. You can detect cats, dogs, and all these kind of things. Maybe you can generalize it to other kind of animals, but you cannot generalize it to segmentation, for instance, right? Because it's narrow. But in the case of the artificial general intelligence, you can do other things there because you can have more capabilities. It's what we call a strong or full AI, right? You have human-like consciousness, or this is the definition, right? Because we still don't have any model that is able to perform like an A.G.I agent, right? You have this kind of sales lane, you can reason about this, you have the ability to communicate with natural language processing and with different kind of languages. And you can also have full generalization. You can plan tasks and you can do all cool stuff that you think like humans, right? This is kind of science fiction, but I think that we are quite close to that. So some examples, as we mentioned very briefly, narrow AI applied to construction services. It will be something like, okay, I have a drawing plan which is quite tall and I want to clean that particular drawing plan, right? I want to eliminate noise there. So what I will do, I can do a lot of things. I can apply a generative adversarial network. I can apply this kind of model, stable diffusion models, a lot of things there. Other narrow AI tasks like text recognition, right? There is a lot of text in our drawing plans, and it cannot be codified as a normal OCR because we have a lot of diagonal text, angles, and all these kind of things. So maybe what we can apply here is like some convolutional neural networks, okay, with LSTM modules to process all the text and to make the recognition and so on. Object identification, we can also perform that, right? With YOLO models, with SDD models, all these kind of things, or even try to separate the drawing plan into multiple layers by making segmentation with spatial pyramid pooling. So we can do a lot of things on narrow AI. And a lot of researchers are focused on that part, right? Not on that one. But what happened some months ago, right? The GPT-4 appears. And a lot of people was started to think, okay, what's happened with that algorithm, right? Because it seems that when I ask him something, it's able to maybe to plan, maybe to reason about that particular task, maybe to provide me a specific output that it seems quite intelligent. So people started to say, if GPT-4, the algorithm itself, because you know that ChatGPT works with GPT 3.5, it's the previous one. So GPT-4, it's more general, it's more powerful in that sense. But people start asking, okay, GPT-4 is showing signs of artificial general intelligence. What is happening here, right? And this is what we will analyze here in detail. So let's go a little bit fast on that, going deeper into GPT-4 technology, right? How GPT-4 is built. We cannot say a lot of things about this because OpenAI was not disclosing anything related to the GPT-4 architecture, even anything related to the training data that they use, the preprocessing strategy, the MLOps stuff that they that they apply to put all these algorithms in production. They didn't say anything, but some AI experts have the intuition to say, okay, how GPT-4 is built, right? So at least GPT-4, basically, it's the generative pre-trained transformer model that uses a transformer-like architecture for better understanding, word by word sequentially, okay? And the relationship that we have between the previous word and the next one. So it mainly consists as well on three different components. We have the encoder, we have the decoder, and we have the tension, right? The encoder is used for transforming the image and the text inputs into vector representation, and the decoder is doing the other way around. It takes the text outputs from its vector representation, right? And then we have attention models, which are not the common ones, which are the self-attention, which is a little bit more powerful, that are using, and it allows the encoder and the decoder networks to focus only on the relevant parts of the input and output. Okay, this is the key point for transformer. So another thing that we need to know is that the GPT-4 is multimodal. You can input images and text. You can do cool stuff. The only thing you need to take into account is that each modality is converted into the same representation so we can fit all these kind of features in the same embedding space. And that's quite important. And finally, GPT-4 also uses some kind of reinforcement learning approach so that we can interact better with the person who is using and who is prompting the algorithm. Okay. What else? What we have inside here? So this was the basic architecture, but that's true that the intuition behind this is that GPT-4 is built based on a visual transformer, which is a little bit more difficult because here we are trying to apply some convolutional layers and then to generate patches that then they are transformed to sequential tokens, okay? But it's also structured with using the Flamingo architecture, which is another thing that it was released some months ago. Okay, this is a little bit more difficult, a little bit more different. It relies also on a pre-training encoder because it needs to process all the images and just transform these kind of pixel embeddings to vectors and tokens and so on. But it's using a thing that I mentioned before that it's quite tricky. It's using cross-attention layers in an exchange manner so that the model is more powerful to focus on what they want or what they think that it's important. Okay? Knowing that and coming back to our use case, which is based on construction services, right? So what we have here, which will be the input for this kind of artificial general intelligence model, is what I talk about, right? It's a multimodal language capabilities. That means that we can input like a raster image. That is what is doing GPT-4. We can input it like some text, the specifications that I think that we cannot see here very well, but this is coming from the drawing plan, something that is joined together when the architect presents the project. But then we can do other cool stuff with data, with the input data and the output data, which is we can accept vectors, right? We can move, as I mentioned before, we can make digitization of the drawing plans to transform pixel to coordinates, and then we can input these coordinates to the model so that we have this kind of context that the image is providing us, but also this kind of vectors, which is like a graph neural network. And then we can use some programming languages about BIM, which is, if you remember, the 3D modeling of an architectural drawing, and also we can just also find some mathematical formulations to simulate this thermal, acoustic, and all this stuff, right, regarding the building. Let's point out a little bit the limitations of that model. So this seems that we talk about GPT-4, it's a very cool stuff, right? It's very new, but it has some limitations. And let's explain very well this, okay? And these are the limitations that we are working on, and a lot of researchers are working on, so that we can move from the narrow AI to a more generalized AI. And this is a key point. The main limitation here is the autoregressive architecture of GPT-4. What does it mean that in simple words? That means that imagine that you want to write or you want to understand like a paragraph, a set of sentences, right? What you will do? You'll do like, you will start reading word by word, right? And then maybe you will think, okay, I don't understand very well this third word, but let's go to the other one, to the next sentence, and let's see what happens if I can reason about this and can understand the previous one. And you are doing, or humans are doing like this kind of backtracking, okay? You are making edits to the text you are writing, you are trying to understand previous word, relating that words with the next one, and you are doing this backtracking. But this, very few times, right? But this is not allowed in the GPT architecture. Why? Because this autoregressive modeling is not doing backtracking. What it's doing is trying to process the tokens, the word, sequentially, okay? So it's not able to do, okay, what happens with the previous word? I didn't understand it, let's go back again. Why it's not able to do that? Because it's not able to plan ahead. And this is a functionality that is required for an artificial general intelligence. So we are not there still, okay? And some of you can ask, you can say, okay, maybe if I prone this algorithm to see, okay, let's do a prone in a different way so that the model can understand very well step by step what I'm asking for, right? This is not as simple like this, okay? Because this autoregressive model is constraining a lot all the things that you are prompting so that the model can act in a sequential fashion manner and process the data and process the words step by step. So we need to change something here, right? So that it can work for us. Okay, very brief, let's go on the path of general AI. This is not only the limitation that we have. As I mentioned, there is other ones for that particular model that we need to just change a little bit, to redefine a little bit the architecture of the whole large language model so that we can achieve this general intelligence. The first one, it's confidence in the calibration, right? What does it mean? Is that, okay, the model has some trouble itself on knowing exactly if it is confident with the result that it is providing you or it's guessing, okay? And this is related to the open domain and closed domain hallucinations. That the model, we cannot specify, let's say we cannot measure if the model is inventing things because it's just relating the prompt that you put and the output that it provides you with the training data. That's not simple, okay? And this is related also to the transparency, interpretability, and consistency of the model. There is no explainability algorithms yet for trying to see what is happening inside these models. And this is a huge issue because we will have a lot of inconsistent content that maybe it will be output very coyly and we can just say, okay, it seems that it's okay, but there will be a lot of wrong things there because they are not matching the training data or they are just mixing weights on things in the meantime, right? This is also related to all of things related to bias, irrationality that you already know. And there is other 3 points that we need to mention, right? Which is continuous learning. It's very complex right now to retrain these kind of models, okay? Because you just train the model, you just fix the weights, froze the weights, and then let's see what happens with the interaction, okay? It's not easy to retrain them because you can cause overfitting or maybe you can degrade the model very fast because you are training with a lot of data, right? And this, although we have some, model degradation strategies when you are putting these kind of algorithms in production, that's not good for this, okay? This is why new researchers mention that, okay, we have all this MLOps stuff, but there is another trend that is appearing here, the MLOps for large language models, because it's very, very different. Okay, let's see how we can, these are some tips that we think, and we just told with a lot of researchers, how we can mitigate, okay, the next word prediction, which is the main limitation of GPT-4, right? How we can change the architecture of this model so that we can make it a little bit more, human-based. There is 3 things that I want to highlight here, right? And we are working on. The first one is trying to introduce this kind of long-term memory in the architecture. So the model, that like recurrent neural networks, like LSTM models that you have like a cell of memory, these models also have this, but this is not enough because we have a long-term memory and this is not codified in the model, right? So this is why we need to change the architecture in some way that we can change the input, we can change the output, and instead of processing tokens representing the text, we can process also a vector that is representing the context. And it's related to what I talk about understanding. So we need to do some of these modifications to the model. Another thing, this kind of fast thinking, right? It's like we are making predictions so fast with GPT-4. You are just prompting something and GPT-4 is saying something to you word by word, very fast, very fast, very fast in real time, right? This is fast thinking. But what humans have is slow thinking, right? Because you are making this kind of backtracking. And this is not allowed in GPT-4 as well, as I mentioned. So what you need is a kind of subfunction, a kind of iterative process, a kind of loop inside so that you can just access to external feedback, external data, you just incorporate it into the model, and then you can correct and review this fast thinking using the slow thinking previously before. Okay? And finally, how we can go beyond the single word prediction, which is very fast so that you can understand, right? It's like replacing this kind of tokens that we are processing sequentially, not in a sequential way, but using a hierarchical structure, okay? So that we can just embed the context of the sentence in a top-down manner. And this will be a key point, and this is what we are working on. So I think that I'm running out of time, right? So thank you very much. So this is what we are applying right now, GPT-4 for this kind of construction services. As you see, we are not still there. We are not in the point of generalizing AI, but we are working quite close. Okay, thank you.